Number 3 tells us to solve negative 2x squared minus 16x equals 20 by completing the square and the quadratic formula. So we're going to do this first by completing the square. Now, in completing the square, remember we want the x squareds and x's on one side, all the other numbers on the other side. And in this case, it's an equation that we're solving. And so we don't need to put like a y in there because we know this expression right now equals 20. And the expression already has the x squareds and x's by itself on one side, the 20 is on the other. We're actually already set up in good shape. The only thing that is keeping me from right away drawing my incomplete square is this negative 2 in front of my x squared. What I want to do is I want to factor that out. And again, we always factor the term out when completing the square. We always factor that number in front of x squared out, even if the other part doesn't divide nicely by that value. In this case, it will, but even if it didn't, we would still do that. So let me make sure this is still working for a second. Okay, I had an error saying that it was working offline. I was just making sure that I was still connected here. Okay, so I want to divide both of those terms by negative 2 and factor it out. So if I divide the first part by negative 2, I get just x squared. And if I divide negative 16x by negative 2, I get positive 8x. And then that still just equals 20. Now I have the x squared plus 8x. That is what I want to need to put in an incomplete square. So I draw my incomplete square for this. I've got x squared. The 8x gets split into 4x and 4x, making x plus 4 and x plus 4. But I didn't just have one of those. I have that incomplete square being multiplied by negative 2. Now on the other side, the incomplete square we draw is just going to be 20. Okay. Now at this point is when we want to go through and complete our square. So the square I made was an x plus 4 square. And so to complete that, I need 4 times 4, which is 16. Then on this side, to complete the square, I don't put the 16 like normal because we have this negative, this negative 2 in front. So because of that negative 2, I multiply that by the 16, making negative 32. That's what is placed over here. So now if I write this in its form, I have negative 2 times x plus 4 squared, because we have an x plus 4 times x plus 4 squared now. Then on the other side, 20 and negative 32 combine to make negative 12. Now I just want to solve this. Okay, if I was putting it in vertex form, this is where we would add the 12, the number back to the other side to get it back equal to the original expression. But that's not what we're doing. We're just solving here. So we're already on the right track to solve. I need to get rid of the negative 2 in front. So divide both sides by negative 2, leaving x plus 4 squared equal to positive 6 when I divide those. Then I'm going to take a square root of both sides to get rid of the square. That leaves, I'll have to kind of come over here to write this, x plus 4 equals, and I just did a square root to help me solve. This is one of those times where we need a plus or minus sign. And then finally, take away 4 from both sides to get the x by itself, and I get negative 4 plus or minus the square root of 6. Remember, anytime you have a plus or minus part, and then you just have a positive or a negative number on that same side, just put that number in front of the plus or minus part. Okay, so when I complete the square, this is the solution I get. Now, if I want to use the quadratic formula on this one, I'm going to take that same original expression, and I'm going to get it in its correct form, standard form, so that I can complete this or use the quadratic formula, because we have to have the a, b, and c values all on the same side. Got to have it equal to 0 first. So take away 20 from both sides to make that side a 0. Then we have negative 2x squared minus 16x minus 20. And at this point, I could go ahead and just do the quadratic formula with a being negative 2, b would be negative 16, c would be negative 20. But I do want to show you an interesting strategy here. You can look and see if there's any common factors that just divide out of everything. And if there are, you can divide both sides by that number. And when you divide 0 by that number, it's just going to stay 0. But then when you divide the left side by that number, your numbers just get smaller and easier to do math with, or just to do basic calculations with. So I'm going to try that because it looks like all these things divide by negative 2. So I'm just going to divide both sides by -2 first. And when I do that, the -2x squared just becomes x squared. -16x divided by -2 is plus 8x. And -20 divided by -2 is positive 10. So x squared plus 8x plus 10 equals 0. Okay. So now at this point, my A would be 1, my B would be 8, and my C would be 10. Now I have 3 positive values. For me, I'd rather plug in positive numbers than negative numbers if I could. So I'm going to do the quadratic formula. It gives me the x values, the solutions to that equation. So I'm going to say the opposite of b, -8, plus or minus the square root of b squared, which would be a squared, minus 4 times a, 1, times c, which is 10, all over 2 times a, which is 2 times 1. So that's -8 plus or minus the square root of 8 squared is 64. Minus 4 times 1 times 10 makes 40, all over 2, which is -8 plus or minus the square root of 24, all divided by 2. Now 24 is not a perfect square. So to simplify that, I'm going to try and think, are there any perfect squares that are factors of 24? 1 times 24, 2 times 12, 3 times 8, 4 times 6. And looking at all of these, only 1 and 4 are perfect squares. So I want to take the factor pair that has the biggest perfect square out. That's what's going to help me simplify it the most. And so that means the square root of 24 is the same thing as the square root of 4 times 6. And the square root of 4 can be brought outside of that to simplify. And we say 2 times the square root of 6. So -8 plus or minus 2 times the square root of 6 divided by 2. And then if I divide both of these top parts by 2, we just look at the numbers in front of the square root and the number at the very beginning. -8 divided by 2 is -4. Plus or minus 2 square root of 6 divided by 2 is 1 square root of 6, or just the square root of 6. And that's good news because that's the exact same answer we got before, right up here. Okay, so whether we complete the square or do the quadratic formula, we're getting the same answer. So that's number 3. Now number 4, I'm going to go ahead and do this one as well. It tells me to solve 2x squared plus 5 equals 2x. Okay, to do this by hand, I'm just going to get everything on one side. 2x squared plus 5 equals 2x. So I would take away 2x from both sides. When I do this, I'm going to go ahead and put it in standard form order. In other words, put the x squareds, then the x's, and then the number. Okay. I would suggest always do that. Don't just stick the -2x on the end. Otherwise, it's easy to accidentally forget and think of that last term as like your c value. But when you do the quadratic formula, a, b, and c are the numbers in front of x squared, x, and then the c is always the number by itself. If you don't put them in the right order, it's easy to forget that. Okay. So at this point, I'll be looking for a way to solve this by factoring, quadratic formula, completing the square. Any of those would work. In this case, I'm actually going to go to Desmos, okay? Because I want to see how to take this original equation and just solve it. So remember, you can take any equation, turn it into 2 equations, and just look where the graphs of those 2 functions intersect, and that solves the original equation. The way we do that is we take the left side, 2x squared plus 5, and we make a y equals 2x squared plus 5 equation. And then we take the right side, which in this case is 2x, and we just make a y equals 2x equation. So I'm just going to graph this and see what I get. So let me double check my equation. So 2x squared, that was plus 5, yeah, plus 5. And then y equals 2x. Now I want to graph this and see. And when I graph it, look what happens. I don't see any place where they cross. So when I graphed it, I'm getting no solution here. So maybe that's our answer, right? Maybe it's just, okay, there's no solution. So when that happens, generally that means, okay, if there are no solutions, it's possible that there may be imaginary solutions or complex solutions that are going on. So what we want to do at this point is now go back and try the quadratic formula or completing the square. We wouldn't be able to factor this one to solve it. So we're going to try quadratic formula for this one. I'm going to say a equals 2, b equals -2, c equals 5. I want to go back to that quadratic where it was equal to 0. Once I got everything on one side, and I wanted to use this. So x would equal the opposite of b, which would be +2, plus or minus the square root of b squared. That's -2 squared. Notice how I always write my negative values in parentheses. If you do that, that just reminds you that when you square it, it's got to be a positive number. Even if Desmos tells you it's negative, it's because it's doing the calculations in an odd order. So -4 times a times c, all over 2 times a, which will be 2 times 2. We simplify that a little bit. 2 plus or minus the square root of -2 squared becomes 4. -4 times 2 is 8, times 5 is 40. So 4 minus 40, all over 2 times 2, which is 4. Keeping this simplified a little bit more, that becomes 2 plus or minus the square root of -36 when I do 4 minus 40, all over 4. Okay, square root of -36. That's a negative square root, which means it's imaginary, right? This is going to be a complex solution. So I want to go ahead and pull the I out and think about the square root of 36. Well, that has a nice square root. That's just 6. So this is 2 plus or minus 6 times I, all over 4. And then 2, 6i, and 4, all of those numbers can be divided by 2. And so that becomes 1 plus or minus 3i over 2. If I just divide each of those terms top and bottom by 2, that just simplifies it a little bit. You could break that up then also and say, okay, this is 1/2, 1 over 2, plus or minus 3i over 2, and put the 2 under both of the terms, or you can keep it separate. So either one of these solutions will be acceptable. Okay, and so we do get imaginary solutions. One thing I want to point out to you is if it tells you to solve one like this, don't just graph it in Desmos and say, oh, they don't cross, so no solution. At this point, you need to be able to, if it's a quadratic, find the complex or imaginary solutions as well. Okay, so just be aware of that. That is the one thing that really Desmos is not going to be able to help you out with. It will kind of give you a hint that, oh, I don't see any crossings, it must be imaginary. But it's not going to tell you what the imaginary solutions are. So you are going to have to know how to go through and do that if a problem like that shows up. Okay, so that's it for number 4.